All right, section 4.2. Here we are, full screen. Oh, yes, here we are. 4.2, section 4.2, graph quadratic functions in vertex and intercept form. So section 4.1 was standard form. Now we have the other two and only other two forms. And here we go, only two vocab. Vertex form. A quadratic function written in the form y is equal to a parentheses x minus h quantity squared plus k. Again, notice that x is squared here. This is called vertex form. And the other form, so the third form we have is intercept form, where it's written as y is equal to some constant a parentheses x minus p times quantity x minus q. And let's rewrite standard form as well down here, just so we can see all three forms in the same place. This is x squared plus bx, and always sorry for the penmanship, it's hard to write. There we go. So all three forms here: vertex form given, intercept form, also called root form, but intercept form, and then finally standard form, standard. And notice that all these have this a in front, and this a again. Big numbers make these parabolas skinnier. Small numbers less than 1 greater than 0 make them wider. If a is negative, all these parabolas are flipped over. All right, let's go ahead and look at the first graph of vertex form. And so how does this work? Well, it's very similar to the absolute value. You could almost replace these parentheses and square with, sorry, that line did not go where I wanted, but with the absolute value. So it's translated, we say horizontally, h units, right? So that shifts the vertex either left or right, a negative opposite of what we were thinking. And we then look at this as vertically. The k aspect moves the vertex up and down vertically. If you have plus 2, you move up 2, negative 2 down 2. The vertex is at hk. So really nice, right? Think of all the work it took to find the vertex in standard form. We had to find the axis symmetry, plug it back in. Vertex form is beautiful. There it is. There's the vertex. Axis symmetry is x equal to h, and the graph opens up if a is greater than 0 and down if less than 0. So let's try an example. So here's our example. We're going to graph this parabola. So the y is equal to 1/2 x plus 1 squared minus 2. So again, game plan. Hey, a is positive. This parabola should open up. A is 1/2. It should be wider than the parent graph. The vertex is at -1, -2, right? We see that, this opposite sign. So our vertex is shifted opposite in the x and y direction. So let's identify a to be 1/2. H here is -1. Again, super, put a little star here. Did that come out? Star here, right? That -1, even though it says +1, but we're familiar with that with the absolute value. And this would be drop 2. Because a is greater than 0, the parabola opens up. And go ahead and plot the vertex at -1, -2. So let's go ahead and do that. That would be right here. Right? Unfortunately, in vertex form, we don't see the y-intercept like we did in standard form. We could solve for it by plugging 0 in for x, right? That might not be a bad way to go. We could also just by plotting points. So we say, here somebody said, hey, let's evaluate. Let's plug 1 into the equation. 1 plus 1 is 2. 2 squared is 4. Half of 4 is 2. Subtract 2 is 0. So right away, there's a point. Point of symmetry, if I shift over 2 units from the axis of symmetry, I could shift the other direction. They gave another point at 3, up 6. Right? And again, we really don't need 5 points to graph. We're pretty good without, but it makes a super parabola. Here we go. And the points 1, 0, and 3, 6, and the reflections. Nice parabola. And again, notice that half, it's a wider parabola. The parent graph would have shifted over 1, up 1, or we're shifting over 1, going up a half. shift over 2. We used to square it and get 4, but half of 4 now is 2. So again, nice to think about the shapes. What about intercept form? This is our last form, so nice that we've almost got all 3 forms under our belt. This guy, we noticed that the intercepts are at P and Q. These are the x-intercepts. Really nice. The axis of symmetry is halfway between them. So we would say the axis of symmetry is halfway between P, comma 0 and Q, comma 0. We would average the values of P and Q. Take an average. We'll see that in a second. If A is greater than 0, it opens up, and A is less than 0, opens down. So all 3 forms, A behaves the same way. So here we go. Example 2, you've got this equation here where A is negative 2, and then quantity x minus 1, quantity x minus 5. So just looking at this, we can tell now that we're going to cross the x-axis at 1 and 5. So let's go ahead and graph those points at 1, 0 and 5, 0. So really nice to get a parabola given an intercept form, because you don't have to solve for those 2, 3, 4, 5. You know, what we don't know is the vertex. We can figure it out. And what we don't know, just looking at the equation, is the y-intercept, right? So each form of the quadratic function has its advantages. Averaging 1 plus 5 gets you 6, divided by 2 is 3. And you can feel that right here, right? Let's go ahead and graph the axis of symmetry. Nice dashed line. It's going to cut every point of symmetry, or set of points of symmetry, in half. If I plug 3 into the function, I'd get negative 2, parentheses 3 minus 1. Some substituting, right? Plug it in. 3 minus 5. It looks like that would come out to 8. So now I should go up 1, 2, 3, 4, 5, 6, 7, 8. Wow, way up here. And again, for us, 3 points. There is your parabola. Nice. And the vertex again is at 3, 8. Well done. I think you need to give these a try. So you've got 2 examples here to work on. First one is in vertex form, and the second is intercept form. Go ahead and hit pause, and when you're ready, I'll show you the answers. And here we have the answers. So in vertex form, awesome. Pick that vertex right out of the equation, 3, 4. Right? The negative A is great. You'll see that the parabola opens down. And then you could plot, I would have probably plotted points here, right? Knowing that A is 1 and shifting over 2 down 4. Either way, how you got there, but the shape obviously very important. And here, again, A is positive and still 1, which is a nice one. Right? Our intercepts are at 4 and negative 2. We average that, unfortunately, well, unfortunately I should say, it looks like it's a half, but careful on the scale. The axis of symmetry is at 1, and then we'd have to plug 1 into this equation, right? We'd set x equal to 1 and solve, and we would get negative 3 times positive 3 and get negative 9. So you got a bit of work there. Nice job. So lastly, we want to be able to switch between forms, and so to do that, a lot of times we have to FOIL. So FOIL, again, just a reminder, is first terms get multiplied, then the outer terms, then the inner terms, then the last terms. I like drawing arrows. X times x, x times 7, 4 times x, 4 times 7. FOIL. And so here, just to speed things up, and my handwriting is so poor, I'm going to show you how to expand. This is in intercept form, and how do we expand that? Notice we have a 3 here, and I would leave that guy alone for a little bit. So first, let's expand the parentheses. So we FOILed, right? The next step would be to combine these 2 middle terms here. And finally, then I would distribute the 3. And you should get your final answer. And let's see, another example. So now we're expanding. This is vertex form, and we'd like to switch the standard form. So again, the first place you want to really hit are these parentheses. And please remember, this is a huge step. X plus 2 is the quantity x plus 2. And then I would FOIL. right? So if you just, common mistake here is to say this is x squared plus 4. But be careful, it's really x squared plus 4x plus 4. And don't forget that middle term. Now we should distribute the 5, right? The 5 would come in and multiply against all 3 of the bracketed terms. And then you've got like terms, negative 20 plus 8. So there's quite a few lines of work here. And you've got your final answer. Again, final answer, look at that, standard form, A, B, and C. Y-intercept's clear here is negative 12, where we can't see the y-intercept when we're in vertex form. Why don't you go ahead and try to do 2 of those. Oops, I already gave you the answers. See if you can cover that up. And go ahead and try those anyways. Hit pause, sorry about that. I should fix that. And I think we're done. So again, try to expand this. I apologize, I put the answers up. I should have held off on those. But if you can, try to expand this, see if you can get this same answer. And finally, expand this one and see if you can get the fine answer. Good practice, and we'll practice more tomorrow in class.